Hey everyone, this is lesson 3.13 in AP Pre-Cal, and it's called Trigonometry and Polar Coordinates. So the foundation of the polar coordinate system is a horizontal ray that extends to the right. It's this one right here that we see in the diagram on the top called the polar axis. All right. Now, this ray has an endpoint in the very center, and it's called the pole. Now, if we're thinking about a regular rectangular coordinate system, this is kind of sort of like thinking about our origin, okay? And almost like our x-axis right there, okay? But in the polar coordinate system, we call this instead the pole for the origin there, and this is our polar axis, all right? Okay, so polar coordinates are always going to be written out as r theta. Very important, okay? And so if we had to plot polar coordinates onto this polar coordinate system here, we're looking for, first thing, where the angle is. Okay, so there's two sets of points here. We're going to be plotting them on this coordinate system. We're two more points over here. We're plotting them over here. And of course, you got two more coordinates that we'll be plotting on this polar graph. Okay, all right, so let's start with the first point. We have 2 and pi over 6, right? Now, the angle is at pi over 6, all right? So this is very important because the first thing we want to do is kind of locate. Now, all we got, by the way, our answer is just the point, okay? Where are we going to plot this point? But there's going to be a few things that I draw in here that might be helpful for you as we learn this process, okay? So the first thing I'm going to do is locate that terminal ray, pi over 6, okay? We have our initial ray right there, and so our terminal ray for pi over 6 is going to be this one right there, okay? All right, so now that we have that, we're looking for 2. Now, when you see 2, these polar axis is labeled with numbers, right? We've got, I know they're really small, but we got 1, this is 2, this would be 3, and this would be 4, and of course, if you need to go all the way out to 5, you will, okay? These are the R values. So since our angle is located here at pi over 6, and the R value is 2, we're going to travel 2 units from the pole along our terminal ray, okay? So we're going to go 1 and 2 units out, and then that is going to be where we plot that point right there, okay? All right, so that point is done, okay? Now let's do the next point there, which is 2 pi over 3. Well, I can see that, I'll do this one in a different color. I can see that 2 pi over 3 has that initial ray, right there at the polar axis, but the terminal ray would be right here where that 2 pi over 3 is located. Now, notice your R value is 2, all right? Okay, that means along that terminal ray, I'm going to travel 2 units. So that would be 1, and that would be 2, and then we end up getting a point right over here, okay? All right, and that's all we got to do for plotting points. Now, of course, some questions are easier than others, right? These were pretty easy, especially because our R value, you notice both of them were positive. Okay, so let's look at some more examples. Over here, we can see that we have -3 and 7 pi over 6. Well, first things first, where is 7 pi over 6? All right, okay, well, 7 pi over 6 falls over here in quadrant 3. Okay, I'm just going to draw that out. And again, you don't need to do this, but I find it helpful while we're first learning the concept. All right, so this is our initial ray, and this is our terminal ray, okay? Now, when we see an R value that's negative, all it means is that we're going to bounce to the opposite side, okay? The official phrase that we like to use here is opposite of the terminal ray, okay? So opposite of the terminal ray would be along that pi over 6 line still, okay, except not on this ray, but opposite of the terminal ray. So bounce over the pole, basically. And since the R value is -3, that jump plus the negative, and then we're just going to go 1, 2, 3, and then our point should be somewhere around here, okay? All right, the next thing that we want to do is go ahead and graph 0 pi. Okay, so 0 pi is at the angle of pi. All right, we got our initial ray there, we got our terminal ray right over here. Okay, and well, where is 0? Isn't 0 at the pole? If this is 1 and this is 2 and this is 3, right? 0 is right here at the pole. So anytime you have an R value of 0, your point is always going to be located at the pole. Okay? All right, so get some extra examples there that you can try on your own, and we'll keep going on to the next slide. All right, so these are some formulas to convert from rectangular to polar form and vice versa. You can use these formulas to convert from polar form to rectangular form, okay? But when you're converting from rectangular to polar, remember that rectangular form is like when you have a coordinate, like an x and a y coordinate, right? And polar form, we just plotted them, that's your r and your theta, okay? So when you're converting from rectangular to polar, it looks like this. All right, first step is usually to plot your point. And the most important reason that we plot the point is so that we can figure out what quadrant we're working with, okay? Next step is to find r, and then the last step is to find theta. And that's kind of why I like to have my students plot the point. It makes finding theta a little bit easier, okay? R could be tricky sometimes, so what we'll do is we'll use the positive value for r. Theta is usually going to be the smallest positive angle with the terminal side passing through our point xy. Okay, so let's start. Let's do an example so we can see how this works. Find the rectangular coordinates of the points with the following polar coordinates. Well, if this is a polar coordinate, that means this is really just r theta. If we're looking for the rectangular coordinates, that means we're looking for the x and the y values. All right, so what we want to do here is we want to use these two formulas at the top of the slide. Okay, so that means that x is going to equal r cosine of theta, and that means that y is going to equal r sine of theta. All right, so since we know that r is 2, I'm going to just plug that in. And we know that theta is at 3 pi over 2. I'm going to plug that in as well. Now we're just going to evaluate this, and hopefully it gives us an x value. All right, so cosine of 3 pi over 2. Well, what is that? Well, let's think about our unit circle, right? In our unit circle, 3 pi over 2 is located down here. And since it's located down there, the coordinate should be 0, negative 1. That cosine value is the x value. So this should give us 0. Now, if I multiply 0 by 2, I'm going to get 0. And that means that my x coordinate is, in fact, 0. Okay? All right, now for the y coordinate, all I need to do is plug in the r value, which of course is 2 again, and sine of the angle 3 pi over 2. So same coordinate, right? Which is that 0, negative 1, but sine is the y value. So for sine of 3 pi over 2, we'll swap that out for negative 1. And when we evaluate 2 times negative 1, we actually end up with negative 2, which means the y value is negative 2. Now, what is the coordinate? Well, the coordinate would be 0, negative 2. All right? So that's what we're looking for as far as an answer goes. All right. You can see there's an extra example. You could do that on your spare time. All right, so how do we go and find a polar coordinate if what we're given instead is the rectangular coordinate? Okay, now the rectangular coordinate is given to us as x, y. And if we're looking for the polar coordinate, well, we're looking for r theta. Okay, and these are those 3 steps. The first step is to plot the point. Okay, well, where is this point going to fall? Let's see. I have a negative x, okay, so negative this way, and then positive square root of 3, okay, somewhere up here. So let's just draw somewhere up in quadrant 2. Okay, if I have a point somewhere in quadrant 2, it's going to fall somewhere over here in this region, right? And then the distance from that point to the origin is what we call the r. Okay, so the second step that I like to do is find r. Well, r is equals to the square root of x squared plus y squared. And we do know x and y. You see, that's given to us. So I'm going to plug those in. X is negative 1. Okay, if I do negative 1 squared, I'm going to get 1. And y squared is just square root of 3 squared, which really should just give us 3. So that means that our r value is the square root of 4, which is great, right? Turns out to be 2. Awesome. Okay, so we just found r. Beautiful, right? Now we just need to find theta. So in order to find theta, that's when we get to use tangent of theta is equals to that y over x, right? Okay, so, well, what is our y value? It's given to us, right? That's the square root of 3. And then x is, well, it's negative 1. Okay, so you may or may not remember this, but basically we're being asked to say, hey, where is tangent negative square root of 3? Okay, and a lot of people confuse this and they have some trouble because they forget that tangent is really just y over x. Okay, so let's do a quick little review on the unit circle and see if we can piece this together. Okay, all right, let me see. I'm going to do a little scratch work down here. So in quadrant 1, we got these 3 common angles, right? This coordinate, of course, is at 0, 1. This coordinate here is at 1, 0. And remember that we count up from 0, so that's 1/2. That's square root of 2 over 2. This is square root of 3 over 2. And then counting up from the 0 going this way, we get that 1/2 over here. Over here we get square root of 2 over 2, oops, square root of 2 over 2, and then square root of 3 over 2. Now, I don't want to use too much room here, but these are the angles, right? Pi over 3, we got pi over 4, and we got that pi over 6, right? Okay, so when does tangent give us, well, in this quadrant, it'll just give us positive square root of 3. So, well, when does that happen? Well, let's see. If we divide y over x, let's do that on the bottom here. If we divide y over x for this coordinate down here, pi over 6, right? If I do that, I'm going to get, let's see, 1/2, that's y, divided by x, so keep change flip. I'm going to flip that to 2 over radical 3, right? These 2's will cancel. I want to rationalize, and I actually end up with a tangent value of square root of 3 over 3. That's the tangent value at pi over 6, okay? Now, if I work out the tangent value of pi over 3, I'm doing y over x. So if I do square root of 3 over 2, that's the y value, divided by x, so keep change flip, which means multiply by 2 over 1, and get rid of your 2's. And notice how we get the square root of 3? That's great. That means the tangent of pi over 3 is, in fact, the square root of 3, all right? And then that also means that if we do y over x on this one, we just get 1, okay? So these are your tangent values that I wrote in purple, okay? Now, again, that's just for quadrant 1, but we know that all students take calculus. So we also know that in quadrant 3, all these values, you know, all your angles here will have positive tangents, right? Tangent values, but then we get those negatives here in quadrant 2 and also negatives here in quadrant 4. So these are the ones I'm interested in. Now, before I just commit to picking an angle, take a look at where we plotted our point, and that's where step 1 comes into play. We plotted our point in quadrant 2, and so that's why I want to select the angle that is a pi over 3 in quadrant 2. So this is pi over 3, this would be 2 pi over 3, you see? And that's also going to have a tangent value of square root of 3, but negative, okay? So I'm going to go with my angle theta being 2 pi over 3. Okay, so since we had to find the polar coordinate, I want to write this thing out as a polar coordinate, okay? R comma theta, so 2 comma 2 pi over 3. There you go. That's our final answer. All right, great question. Okay, let's do more. We got this next one here. Find the polar coordinate of the point whose rectangular coordinates are -2, 0. All right, we'll do the same thing. Since we're looking for that polar coordinate, same type of question, right? 3 steps, right? Plot the point, find R, and find theta, okay? All right, first step, plot the point. So where is -2 comma 0? Well, -2, 0 is over here, right? And then the distance from that point to the origin, well, that one's easy to find R, isn't it? Isn't R just going to be 2? Yeah, right? Now, you could work out the same formula, but when we do square root of 4, right, because -2 squared is 4, plus 0, we end up with square root of 4, which again just gives us 2, okay? Step 3, tangent of theta, that's equals to that y over x, right? Okay, so what's y? 0. What's x? -2. All right, so now we're like, hey, where's tangent going to be 0? So let's go back to our unit circle for just a minute. We started going over all these points, and we wrote down that this coordinate was 1 comma 0. And if I was to do y divided by x, 0 divided by 1 gives me 0 for this tangent value. So I'm just going to write 0 here. So I mean, I want 0, right? I'm looking for 0 in this particular question, but notice that my point, again, we always come back to step 1, my point was plotted on the left side of the x-axis, which means really I think I'm more interested in this side. And that coordinate is -1, 0. Now, if I divide y over x, do I still get 0? Yeah, I do. So the angle that we want to submit for theta in this case is pi. Okay, so we're going to go ahead and say here that theta is going to be pi. Okay, so once you find r, once you find theta, write it as a polar coordinate, which would be r comma theta, 2 pi in this case. All right? Okay, hope that's not too bad. So the next thing that's part of lesson 3.13 is plotting complex numbers in the complex plane. And this is actually a very simple concept. We know this is our x-axis, but when it comes to imaginary numbers or complex numbers, we would like to call this instead the real axis, all right? Which means that our y-axis is really going to be renamed to become the imaginary axis. All right, complex numbers are always going to be in the form of a plus bi, where there's a real part, that would be your a, and then there's an imaginary part, which would be your b. All right, so let's jump in. All right, oh, and by the way, these are called complex planes. All right, so if we had to plot these complex numbers in the complex plane, look for each number. Each number has a real part, right? Okay, so in question A, I guess, we have a real part of 3. Well, if I had to plot that on the real axis, I would just count them out 1, 2, 3. And then I have an imaginary part, which is 4. And so from here, I'm just going to go 1, 2, 3, 4, and I get to plot my point right around here. Okay, so that's where I can plot question A. Okay, now for question B, this one also has a real part, right? That would be -1. So -1 actually takes us to the left one. But it also has an imaginary part, and that's -2i. So from here, I'm going to go down 2 units. You see, and then that right there is where we could plot question B. All right, for question C, there is a real part, right? But is there an imaginary part? It's like having 0i at the end, right? And so basically, we have to go 3 units to the left, so 3 units to the left on the real axis, right? But we're not moving up or down on the imaginary, okay? So we get to keep it right there for question C, all right? And for question D, which is -4i, this is really like having 0 minus 4i. So our real part is 0. So I'm not going to move from that 0 on the real axis. You see, I'm going to stay right there. And then I'm just going to go down 4 on the imaginary axis. So 1, 2, 3, 4, which will put me right here for the question D. Okay, so pretty easy process, nothing too crazy. You should have no trouble plotting complex numbers. All right, so the next thing I want to talk about is absolute value of complex numbers. Absolute value of complex numbers just uses that real part and that imaginary part with that absolute value around it, okay? And basically it's the square root of x squared plus y squared. But if you notice here with the complex number using a and b, well, the formula's changed up a little bit, right? And it's square root of a squared plus b squared. But keep in mind that if you have that x plus yi instead of a and b, well, then it's just really your r formula. Look at that, okay? So ultimately, the absolute value of a complex number, and I just want you to read this note here, this is the distance from the origin to the point. That's r. And that's why this is the same formula that appears. So this is really just an application of finding that r, okay? So let's do this, all right? We determine the absolute value for each of the following complex numbers. Okay, so basically do that. Okay, so let's look at question A. So if I'm going to take the absolute value of this complex number, that just means it's the square root of 3 squared, which is 9, plus 4 squared, which is 16. Now this is going to add up to 25, so that's radical 25, and that just becomes 5. All right, so that's pretty easy. Doing one more just in case, right? Absolute value of this number, well, that's just going to be the square root of -1 squared, which is 1, plus -2 squared, which is 4. Now this does give us the square root of 5, but that's the exact value right there, okay? I'm going to go ahead and say that's my answer. I would need a calculator to evaluate that, and let's just say there's no calculator available for this type of question. Okay, next thing I want to talk about, polar form. Oof, big lesson, huh? Polar form of a complex number. All right, so complex numbers that we see in a plus bi or even x and yi, right? They can be written in polar form. Remember, you can always find the r, right? You can always find the r, you can always find the theta, okay? And once you find r and once you find theta, you can write it into polar form. Take a look. Polar form is just to say z equals, that's just the number equals, r, parentheses, cosine of theta plus I sine of theta. In other words, if you find r, you can just plug that in right there to that equation. And if you find theta, you can just plug that into that equation, and that's it, because you're going to leave it with the I. It's a complex number after all, okay? Anyway, so I went ahead and wrote here a is equals to r cosine of theta. Remember, that's the same as saying x equals r cosine of theta. B equals r sine of theta. That's the same as saying y equals r sine of theta. All right. Didn't mean to confuse you with the a and all that, but you know, sometimes this could be x squared plus y squared, right? And that's our r formula there, okay? And then tangent equals b over a, also known as y over x. All right. I didn't mean to confuse you. It's just sometimes we do see different notation. All right. So plot z equals -2 minus 2i in the complex plane. All right. So this question has a couple parts, but let's start with that because that seems to be the first part of the question. If I had to plot this complex number, I know I'm going -2 on the real axis down to, because I have imaginary part of -2i, and that's where the point falls. Now, could I find the r value, right? The distance there. Yeah. I could find the r formula. I'm sorry, I could find the r value by saying r equals the square root of x squared, -2 squared is 4, plus -2 squared again, which is also 4. And this just gives me the square root of 8. Now, can I simplify that? Yeah, I could, right? Think of your factors here of 8. We have one to be the square root of 4. We have another one to be the square root of 2. And this just gives me 2 radical 2, okay? So this right here is your r value, okay? And then theta is going to come from that tangent of theta, which is equals to y over x. All right, now do we know what y is? Yeah, right, it's -2. And do we know what x is? Also -2. So this gives me 1. Now, where is tangent 1? Well, we know, we talked about it earlier, but tangent is 1 at pi over 4. Right? But pi over 4 is not exactly where our point was located, right? Pi over 4 was here in quadrant 1. So remember that in this quadrant, we got 3 pi over 4, and in this quadrant, we got 5 pi over 4. So we're going to say that theta is 5 pi over 4, okay? So this time, I'm not going to list my answer as a polar coordinate because notice the question doesn't say write the polar coordinate. Instead, it says write z in polar form. Well, what's polar form? Okay, we'll say z equals r. I'm just going to follow this form right here that I have in that purple box. R, which is 2 radical 2 times cosine of theta. Okay, that's cosine of 5 pi over 4 plus I sine of 5 pi over 4. All right, and right there, that is your polar form. Same thing, but you can see the answers in a slightly different form. All right. Okay, and then I just have one more slide to go. If you have this polar form, that's what we're looking at here because I could factor out the 3, that's our r value. Convert the polar complex numbers into a rectangular form. Well, in polar form or in complex numbers that are in polar form, remember that rectangular form would just be x plus yi, okay? So how do we do that? Well, let's think about this. Could we find cosine of pi over 3? Feel like we did that unit circle somewhere, right? And where did we do that? Let's see. Oof, way back here, right? Okay, so at pi over 3, remember we got 1/2 for the cosine and square root of 3 over 2 for the sine. So I'm going to fill in some of these values. There we go. So cosine of pi over 3, remember, that's where we're getting this 1/2 from, okay? That's the x value from that coordinate, times 3, plus, I'm going to put the 3 in there, times the I in there. So I'm just going to multiply 3i, and then could we evaluate sine of pi over 3? Remember, that's the y value from that coordinate, which should have been that square root of 3 over 2. Okay? All right, so let's see. Could we multiply these things? Yeah, I mean, we could, but ultimately, this is just going to give us 3 over 2 plus, and then if we multiply the 3 times this square root of 3, we're just going to get 3 radical 3 over 2. And then where do we put that I, right? If we put it back here, sometimes students accidentally put it inside of the radical. So we can either put it here in the front. If you want to put it back here after the 3, that's fine. Please don't forget about your I, okay? Anyway, this is like the real part now. and this is the imaginary part. Okay, we could do it here as well. Sometimes it's easier if that r value is factored out. Cosine of 3 pi over 2, you might remember the coordinate of 3 pi over 2 is the one that was down here, and we wrote out to be 0, -1. Well, cosine of 3 pi over 2 is 0, plus, let me bring this down, sine of 3 pi over 2 is -1, right? And then I need to multiply all of this by 4. So if I multiply by 4, I'm just going to get 0, right? And if I multiply by 4 here, I'll get -4i, okay? So there you go. You can see how we would convert into rectangular form, how we'd convert to polar form, how we'd write polar coordinates, how we'd write complex numbers, right? All that fun stuff. We learned how to plot points in the polar coordinate system, how to plot points in the complex plane. This was a big section, okay? But that wraps up 3.13. All right.